I would like to first get started talking about some issue about lab number 1. I think you're supposed to write all the test cases yourself, but I think the trickiest case for you to write will be to write post-condition tests. So I'm going to give you some example here. So hopefully it can help you. And you may, I'm not sure if you might like this, I'm going to extend the deadline for lab 1 for a few days, if that's okay. Good? Good. Okay. Well, guys, but, I would say you really have to take advantage of the few days to write more test cases because the post-condition is really important. About 52% of my grading tests are about post-condition tests. So you really have to be careful. Okay? So now I would like to talk about how you can test post-condition. Okay? I want to start with that. Okay, guys. Okay, I'm going to make a formal announcement to the email about the due dates. So it's going to be Friday noon, okay, rather than Wednesday. Okay, so now this is what I want to do. Let me sketch the idea. The reason that I didn't talk about this technique about testing post-condition is because it's going to involve something called inheritance, which we will talk about a little bit later. But since for this particular lab, you really need to test the post-condition before you submit. So that's why I'll mention that to you. You can follow the technique very easily. Okay? Let me just talk about the idea. Remember, we have the array container class. I'll say called the AC, array container. One of the features which I already give you everything is the assign at feature. So we have I and we have S over there. Remember what I said before, if you want to test for post-condition violation, you have to temporarily make some wrong implementation in the class and then change it back. So there is a much better solution to this. The idea is as follows. Every time if you want to create a bad version of your array container with a particular wrong implementation, what you can do is, for example, you can just inherit, so this means inherit. Inherits from array container, I can just call it, for example, bad array container, and then let's say I'm focusing on assign at. So this is just a brand new class. And everything I do in this class over here is to redefine the way we do assign at, which is going to be wrong. And then in your test case, let's say in your case you say test array container. Over there, you're somehow going to refer to this particular class, not the correct version anymore. Okay, that's kind of the idea. And when you are trying to make use of this bad version there, it is supposed to throw some post-condition violation to you. Okay, that's the idea, first of all. Is it clear? Okay, so now I'm going to show you how you can do that. Okay, let me just open Eiffel Studio. I'm going to start with the starter code I gave to you. And then let's do one example together. I'm going to create a bad version of assign at and see how the post condition can catch that. Okay, that's kind of the starter code you were given. So now I'm just going to create another class under instructor. I'll make the code available to you after class. Okay, what you're going to do is you're going to say add a new class. What about test? Let's say bad array container, for example, and say creates. Let's just set this up very quickly, and I'll show you how you can create an inherited class. You'll say inherit es test create make feature make, and we're going to add a violation case over here. I'll do that in just a moment. Okay, so now we're going to have test post condition failure. Okay, let's see how we can do that. Before I do that, let's just compile, first of all. Make sure everything compiled. Now, if you remember, if you go back to array container, so now I somehow added a correct implementation for insert last, which I wouldn't show you. That's part of your job. Okay? What I'm going to do is, I'm going to go to the assign at feature here, which it got everything already. What I said before, you should really uncomment this wrong implementation temporarily. Let's not do that. It's not really systematic. It's a bit not so convenient, it's ad hoc. what I want to do is I'm going to create a new class, a subclass of the array container. And then I'm going to have this implementation. Okay? And then we'll test that bad version specifically. Okay, let me just go back there. And then let's say under instructor, in your case, maybe under the students cluster. I can have a new class over here. I'm going to say, let's say bad array container. In this case, I'm creating a bad version for assign at. Okay, I'm going to say creates. Okay, so now, let's see what we can do. First of all, I don't necessarily have to build up the array container from scratch. I don't have to. I just have to redefine or overwrite the feature I want to redefine. So first of all, I can say inherits array container over here. And then I also say the constructor is still the make. And then I'm going to redefine some feature. Creates a bad version of assign at. Okay, here's the thing. You don't have to understand the inherit clause in every detail, which we'll talk about a little bit later. For now, let's say I want to redefine a particular feature under inherits. I would say redefine. Okay, redefine assign at. I'm saying I'm going to redefine this particular feature only. Everything else is inherited from array container, pretty much like in Java. Okay, so now how do we create a bad version? I'm going to say assign at, the signature must match, which means I, integer, and then S, string, like that. Let's compile. Okay, everything still compiles. So now, remember back in Java, you learned a keyword called super, right? Super simply means I'm going to refer to the parent version of this method. You got something exactly similar in Eiffel, which is called precursor. Okay, so now I can say first call, I'll make a comment here, first call the inherited version from array container. You can say precursor. In Java, you would have just said super and then with that argument. Here you say precursor, I and S. If I only stop here, everything is just the same as before. But now I'm going to add something that's not correct. So here comes the wrong implementation, which should trigger some post-condition violation. Okay, let's try that. Let's say, I'll simply say this. Since we are only supposed to assign at a particular slot, like an index I would say if I happens to be larger than 1, I would just do I will also assign the 1 to its left. I can say implementation, which is inherited from the superclass, imp, and then I would say I minus 1 is assigned to S. Or I can make it even more explicit, bad. Okay, this part is really bad. Compile, everything compile. Okay, so now we do have a bad version over there, right? We do have a bad version over here that we just created. Right? This is a bad version over here. So now we're going to do a test from there. And what is so special about it is, that's something we'll talk about a little bit later. Whenever you inherit, when you learn in Java, you only inherit the code. In Eiffel, you inherit also the contracts, right? Which means, let's say if I say ensure over here, ensure, for example, some predicate P, which is a Boolean. Somehow assign at will also inherit the same postcondition P. So it will be checked against this wrong implementation. So what we will do is, in the tester over here, we're going to declare a variable, local variable of this type, the bad array container. And then when its implementation is actually wrong, it is actually run, it's going to violate the postcondition. If there was a postcondition violation, that is good, because you do catch the error. If there was no, then there's something wrong with your postcondition. And this is exactly how I test your submission later. Okay, let's see how we can do that for this example here. So let's go back to the test bad array container over here. So now let's declare, let's say test bad AC assign at. Okay, now let's do a comment over here. Comments, you can say this is a test which should trigger a postcondition violation. And we should really be specific about which one specifically it will trigger, because there are actually more than one postconditions for your assign at. Okay, we'll get there in just a moment. Let's now declare. Now I will say local here. Notice that I don't say array container anymore. If I do this, it's no different as before. What I would do is I would say bad AC assign at. Okay? Everything is, but the public interface is the same between the two classes. So now what I would do is I would say create AC dot make, or you can just make it a little bit more familiar to you. Create a container which is empty, and then I would say AC dot insert last, which I already added some implementation, so it's correct. So let me say A over here, and let's just add another one. Okay, I would say B over here. So now, so far we're just building up. So now we are at the point that we're ready to test. So now we can say AC dot assign at, let's say we want to assign at position 2, and we want to assign that to C. What we really expect to occur, it should be A and C. However, remember, this is what you can try. If you highlight this, right click and say pick feature assign at, right click and drop. It will bring you to the version that will be called, which is this wrong version there, right? It is not only going to change position 2, but also it is going to change position 2 minus 1, which is bad. Okay? So far so good? Let's go back there and see, and what we expect to see is some postcondition violation. So let me just go back to our array container where we define the postcondition. Over there, let's have a look. So which one should it violate? I'm expecting this one to be violated because others unchanged, which means only position I should be changed. Everything else should be the same. But apparently that one is going to violate this because it also changes I minus 1. I'm expecting this tag to be violated, so let's go back there. So what we can do is we can say at violation case with tag. So I'm going to paste that tag there, and then I'm going to say test. Okay, just do that one there, and don't forget you should use agent. Okay, everything still compiles. Before we run, make sure you add it to the test suite. So go to the root class and go to test containers. To avoid distraction, I'm going to comment this out. So you can simply say something like this. So here I can say add test. Okay, we can set test bad AC. Okay, so now if you do that, run workbench system. We do have that postcondition violated, right? Now, let me just show you something, okay? Everything seems so smooth, right? That's because I knew the stuff, but you have to really practice. Let me just go back there. Let me just change something so it will fail. For example, if somehow you put the wrong tag, let's see, if you go back to array container, if I somehow expecting this one to fail, that's wrong, right? If I just replace this back there, compile, and then run, it's going to fail. There was no postcondition violation like that tag, right? So what you should really do is to undo that tag. Okay, let me undo that. Okay, compile, and then do it. Okay, any question about this mechanism? Yes.
Do we need to submit all these files?
You don't need to. So basically, but you know, when I grade your submissions, I'm not going to look at these tests that you do. The reason that I'm showing you is you can gain more confidence before you submit. So that's exactly what I'm going to test your code. I can just give you some number. I had about 50 tests. that I'm going to run on your submission. So if you got somewhere close to that, it's a good sign. But I should really try to test for every post condition. That's my point. Yes?
Since we're writing the post conditions, then I wrote one that was too objective, and I realized writing the docs that it should have been fixed. It's kind of like testing, but then you're testing your own code, which is still with your code.
It's okay. You know, in some way, the tester, even though it's written by the same person, but it's more from a client's point of view, right? So here you can see, for example, in this case over here, we are basically using a surface that's actually really bad, because it somehow changes not just position I, it also changes position I minus 1. But how do we catch that? It should be caught by your original post condition. If your post condition doesn't catch that, it's a sign that your post condition is not strong enough. That's kind of the. Okay, any questions? Yes. It's a very good question. So I would say to really avoid confusion, right? You can see now for me to test this particular bad implementation there to trigger a particular post condition, I created a separate class. I would say for every post condition you want to test, create a separate class, which is okay. I created about maybe 10 or more new classes just for these purposes, but that would do. Yeah. Try not to really inherit from array container and then create so many bad versions. You may just get yourself confused, right? Yeah. Guys, any questions in terms of reproducing this? Of course, you can also rewatch the video. Yes, get down. Yeah.
Should we want to create a different class for each test case?
Only for the post condition. Remember, eventually, the one I'm going to run for your project would be, I'm going to run the class called test array container, which you're supposed to create. Any other extra classes you create, it's okay to submit them together. That's okay. But your final project that's being submitted must compile. Okay, so I'm going to open the submission site early afternoon tomorrow. So when you submit your project, it's going to try to check the file structure. For example, you got the student, you got the instructor clusters, also you got your class under the student cluster, things like that. And also it's going to check that you got the XML diagram source, you got the PDF diagram, etc. Once you got the expected file structure, it is going to compile your Eiffel code. If your Eiffel code simply doesn't compile, it's not going to proceed any further. It's going to tell you, so you can resubmit. Once it actually compiles, it's going to try to run whatever test cases you have got in your test array container class to see if there's at least 10, and every one of them actually pass. If you satisfy all of these, you pass all the basic checks. But passing all the basic checks doesn't mean you're going to get 100%. You still have to pass all my test cases, right? But I would say really, as I said before, about 52% of my test cases are stuff like this. So that's why I'm trying to show you today, so you still have time by Friday noon to really try to run things like this. So the idea really is you're trying to create a separate version of the array container that is bad, and try to use that to be caught by the inherited post condition. That's kind of the idea. Questions? Yeah?
Will we get any examples posted or no?
I will post this one, no problem. Yeah, I'll definitely do that. Maybe I will take out the correct implementation for insert last. Other than that, everything's there. Yeah, I'll make it available to you, don't worry. And I still have the office hours on Wednesday. Oh, sorry, not Wednesday, Tuesday. So you can still ask me tomorrow. And for Wednesday, since the lab has been extended, I think I will still release lab number 3. Okay, so it will be up to you, because some of you might be ready to start with the next lab. You can feel free to do so, but we will be there to help you with lab number 1 if you still want to work with that, if you got choices. Huh? Lab number 2, that's what I meant. Yeah. Sorry, I got confused with 2030. Any questions before I move on?
Yeah, because we want to test post condition, that means we add new files to the files.
Yeah, that's okay. That's okay.
All
yeah, so what you really want to remember is whatever you submit must compile. If somehow you use the new classes I just said, but you didn't submit them, your project is not going to compile. That's not good. So the structure I set in the instruction is only the minimum structure. If you get anything more than that, that's okay. Okay? If you're not sure, just try. If you run into trouble, just let me know as soon as possible. Okay? Okay, any more questions? But if you got questions, you can feel free to email me. I'll try to respond as soon as possible and also drop by my office hour. Okay. If no questions, I'll move on. Okay. So today we'll continue with the classes, and we'll talk about the uniform access principle, which you kind of experienced already a little bit in this lab number 1. And also, if you have tried to follow the tutorial, we also got another example of uniform access principle. It's not specific to Eiffel, but also in Java. Okay. Okay, and today there are several topics I would like to go over. Okay. Let's just go over again some slides. Okay, so last time we talked about abstract data types. Okay, very quickly. So usually when you're given a problem, let's say array container, you're required to filter out all the irrelevant details. For example, the features you're required to implement for array container, there are only 5 or 6 of them. I didn't really give you 100 or 200. The thing that's relevant is only 6 features. So usually when you're given a problem, you have to figure out what exactly are the problem you're going to focus on. Okay, and abstract data type, we have more. So now we have ADT. So I showed you this picture last time. So the data structure you use, either array, linked list, hash table, is going to be hidden. You're going to say exported to none. Also, you got some public request and result to be communicated with the clients. Okay, we'll talk about obligation and we'll talk about benefits. Okay, so this slide is very easy. So now, why are we building abstract data type? So you have been doing something very similar back in your previous Java courses. Let's say you declare some interface in Java and they have several different implementations. That's one way to look at it. So why do we need abstract data type? We want to have reusability for your software. Every time if you have something that has been built already, why not build again? You don't have to reinvent the wheels. So we got many standard ADTs like stacks, queue, list, dictionary, etc. Okay, and then so now for you as a supplier, you may want to use some other ADTs that have been built for you. For example, array is an ADT, linked list is an ADT, right? So you can use them. And also, if you're simply just trying to build out some application, you can also reuse the ADT. Okay, so now as a supplier, you should really implement using. You can choose the efficient data structure. Let's say in Eiffel, I'm going to have you try maybe the hash table in some later labs. So far you have seen arrays. The way to use linked list is very similar. I'm going to give you some guidance for your very first lab test. But one of the direction can be, let's say we want you to redo some features in lab number 1. But now, rather than arrays, I would like you to implement in linked list, right? So what should be the change? That's something that's worth thinking about. Okay, so now you should really be careful. So now here's the thing. So what's really the requirements for a good ADT? Is Java interface good enough, or we need something that's better? First of all, the first criterion is your supported operation should be very clear. It should tell you at least a method signature. In that case, yes, Java interface does tell you the method signature. And however, in that case, as we learned before, Java interface doesn't really tell you exactly what the preconditions and postconditions are. So if you really try to compare that with what you can do in Eiffel, Java is not really an acceptable ADT. I'll show you one example in the next slide. So, for example, how are the clients are supposed to use the methods? In that case, you will see some illegal argument exception. But again, as we said before, the illegal argument exception you have in Java is not exactly precondition, because the precondition is supposed to have you think positively. You should think about under what circumstances I should run the method. But for illegal argument exception, it's the opposite. It's a kind of the logical negation, right? Okay, precondition and also postcondition. So now that you learned about the across syntax in Eiffel, how would you do that in Java, right? They don't really have such construct. I think the best you can do maybe just to run some loop and then record the value for the loop, maybe in some local variable, and then assert that the variable should be true, something like that. So now it's good. Okay, so now let's consider why Java interfaces is not really a good ADT. For example, you can go to the website for the Java ADT. Let's say we talk about list. You can go to the link. So there's a link over here you can go. But now let's just see a part of it. So this is the interface, and we say interface list. And somehow we have this E over here, which we will talk about today. It's something called generic parameter. Somehow we are parameterizing the element type of the list using E. So it can be a list of person, it can be a list of string, it can be a list of integer. So E can be instantiated into different types. So that's something good. And over here, however, you can see that the way they describe the ADT is just by some natural language description in English. Sometimes it can be intuitive, but when you get to the methods level, it's not as good. Okay, let's see what I'll show you. Okay, especially for methods, hopefully you can read it. I'll read it to you. So we are considering a method called set. So set is similar to the assign_at method you have for array container. Remember in the Java API, there's a distinction between method summary and method details. In the method summary, it simply say replaces the element at a specified position in the list with the specified elements, and that's it. It doesn't really tell you what exactly you will get after this method is executed. What if the implementation try to change somewhere else rather than just the index I, right? That's something we are trying to catch in Eiffel by writing some complete postcondition. Even if you get to the method summary, you will see that they have, again, the set feature here, the set method, and again, they tell you just some natural language description. Again, it's very informal. There's nothing that will actually constrain them to the way they implement the service. Okay, so that's not good. Well, maybe the best part they have is they tell you that if the index is out of the range, they'll give you some illegal argument exception. That might be the closest one to what you can do in Eiffel, but still, it's far away from complete. Now, what have we done in lab number 1? What we try is, we try to define some ADT. In this case, we call array container. Remember in Eiffel Studio, you can simply just go to the contract view, which will show you the precondition, postcondition, and classing variants only, and nothing else. Okay? In that case, we have assign_at. So up to now, this is pretty much like what Java interface will give to you. They simply give you some English description and tell you what the parameters here really mean, and that's it. But what we can do in Eiffel is we can do some valid index here, and we can do what we talked about before. You can say not only that the count should be the same, but also this particular slot at index I has been changed, and most importantly, you want to do some universal quantification, right? You want to say somehow everything else other than I has not been changed. So these are kind of the postconditions that's kind of difficult to write in Java, right? So that's why we say Eiffel is a much better way, as a much better language for you to express ADT. Okay, any questions until now? No? Are we okay? So far? Okay, so now after this, for your assignment 1, don't forget that part 2, you also have to draw a design diagram, right? So this is what you see from the instructions. So this is something we really want you to also master on producing some professional documentation. So we don't want you to simply just copy and paste the Eiffel code to the diagram. That's not what we want you to do. You can see that for this particular part of across, we said that before, this corresponds to somehow corresponds nicely to some universal quantification. That's why what you have over here can be precisely specified over here as a universal quantification. So when we evaluate your diagram, we don't want to see any Eiffel syntax on the diagram for the postcondition. Wherever you can use conjunction, use conjunction. Whenever you can use implication, use implication. Whenever you can use universal quantification, use for all. Okay, don't use across. Okay, any question about this? And in the diagram, you can see that it's pretty much corresponding to the contract view of what you can get from Eiffel Studio, except that we are trying to use math over here to make things precise. So presumably for your clients, if they want to use array container, when they look at the post condition over here, it actually guarantees them a lot to say we are trying to do no more and no less. We only change this particular index I, not anywhere else. Okay, that's kind of the advantages for being precise and mathematical. Questions? Are we okay? Good, good. If no questions, and that's about the ADT. That's what I want to say for now. So now when you draw the diagram, I would suppose you try to do that sooner rather than later. Don't try to draw that in the last minutes. It will take some time. You have to include every feature in your array container in the diagram. It's okay to have several pages, that's fine, but everything has to be included: precondition, postcondition, and class invariants. Yes?
If I have a subclasses, I need to put like another diagram from you.
Oh, so only include yeah, good question. So now that you know how to create additional classes to test your postcondition, you don't need to include them in your diagram. You don't need to, okay? Only include array container. For lab number 2, you will have to do another application with more classes involved, in which case you have to draw more than one classes, but not for lab number 1. Okay? Yeah.
So for this one, we would have one gigantic array container.
Yes. You'll be okay if you somehow separate that into 2 pages. That's okay. Just find a good way to organize them. Okay? Okay, questions before I move on? Yeah. Oh, you mean over there? So I would say over there, it's kind of controversial, I agree. So in principle, the client shouldn't see it, but somehow you're trying to show me the design. So somehow you're trying to say, we are trying to hide this particular implementation from the clients. So I would say to include it or not is optional. Here, I'm just including it. So the question was, over here, you can see the feature here, exported to none. Anything that's private should not be in the public view of the class. That's right. But now, since I'm trying to present the design to you, I'm trying to tell you what has been hidden from the clients. So that's why I'm including that, right? Any more questions before I move on? Yes?
Because the use that I agree will hide, but what in the insurance requirement, it still shows
in the insure, it's okay because insure is somehow is for the supplier to somehow guarantee what should be done, right? So the supplier is guaranteeing that not only that just I spot will be changed, but everything else will be unchanged. So that's why imp will also occur in the insure. As long as the required clause does not contain any private feature, then that'll be okay. Okay, any questions? Are we okay? Good. All right, let's continue. Now, I want to do one small case study here. I'm not sure if you have seen this example when you learn about Java interface. Maybe you have, maybe you have not. If you have not, that's great. So that's a new example to you. I want to explain the uniform access principle. If you have followed the video for the tutorial, the way I explain the uniform access principle is by using the attribute or query balance over there. So I'm going to use a different example here. Okay? Okay, so now let's talk about how we can solve the problem of two-dimensional points. So you know, typically, if you talk about two-dimensional points, you talk about x and y coordinates. So let me just go over this idea very quickly with you. Okay, how do you represent two-dimensional points? There are basically 2 ways you can do it. Okay, let me do it again. Okay, so now how do we solve the two-dimensional points? So 2D points. So there are basically two systems there. So the first one, which is the most straightforward way, is Cartesian system. Cartesian. And the other way is polar. Okay, so this is more from the supplier's point of view. Okay, so we are now talking about supplier. Okay, let me explain to you what that means. Let's say for the Cartesian system, if I'm trying to represent this particular points, it's easy. I simply just record or to store the x coordinates and the y coordinates for P. That's it. Just x and y. Okay, that's easy. On the other hand, for the polar system, which might also have its advantage, the issues, the representation is slightly different. The way we do it is, let's say for the same point P, we do not store x and y anymore. The way we do it is by thinking about, so this is origin. From P to the origin over here, there's a line over here. We record, first of all, the length of this distance here. And also, we also record the angle phi over here. Okay? So these are the two things we record. The distance and the angle over here. So now, why don't we review a little bit math, trigonometry, right? So now, how do we convert from the polar system into Cartesian system? Let's say we decide to adopt the polar system, let's say, right? Well, I heard something that sounds promising, sine and cosine, right? So now, let's say over here, how do we define this, right? It's gonna be x and y over here. X over here should be r times sine. Okay, this will be r times cosine, right? So basically like that. So this will be the cosine, this will be the sine. So for cos, y is sine, yes. One is cosine, the other one is sine, yes. Okay, that's the polar system. So given r and the angle, you can calculate the x and y using sine and cosine in the appropriate manner. Okay? Okay, so far, are we okay? That's from the supplier's point of view. From the supplier's point of view, so now think about this. If you talk about the Cartesian system over here, for x and y, you can simply store them as attributes. That's one way to think of it. You simply store x and y. Whenever you want to get x coordinates, just return an attribute value for x. If you want a y coordinate value, just return a value for y. Okay, that's for the Cartesian system. What about the polar system? Let's say all we care is to get the x and y coordinates. But now, since we are only storing r and phi over here, let's say if I want to get x, can I just return some attributes? No, I cannot, because the only thing I store over here is r and phi, only the distance and angle. If I want to really get x or y, I have to do some additional computation, right? In this case, if I want to get x over here, I need to say r multiplied by cosine of phi. For y, I need to do another computation, which will do r multiply the sine of phi. So additional computation, right? So we got two systems here, right? Now, so far we only talk about the supplier. Let me just draw a line over here. Above the green line is all about the supplier, in which case you may choose to do either Cartesian or you might do polar. But what about from the client's point of view? If I'm going to use your point class, do I really care which system you use? I shouldn't care. Remember what we said before, the client shouldn't worry about how the supplier implements their information, right? Like for your array container, so it shouldn't really matter how you support the features, either linked list, or you can even use some other data structure. So now that's from the supplier point of view. What about for the clients? All they really care is whether they can use x and y, and that's it. But when they call the x and y, they might be done differently depending on how the supply implements that. So I'm going to show you. So far only to sketch the idea. The idea is somehow to really access x and y, the uniform access principle in Eiffel, it's also in Java. In Java, basically, whenever, I'm going to talk about Java in just a moment. In Eiffel, if you simply say p.x and p.y, let's say p is of type point, p.x, p.y, you cannot really tell whether x is implemented as an attribute, like in the Cartesian system, or is implemented as a query, like in the polar system. Also, in your lab number 1, you also have the choice, right, for uniform access principle. What is that? Lab number 1. Which feature is that? The count, right? Yeah, so for count, you can either choose to implement that as an attribute, or you can implement that as a query. It's completely up to you. But typically, if you want to implement something as an attribute, the catch is you have to update the attributes when necessary. For example, if you want to insert add, you want to update the count by some appropriate size. If you only implement the count as a query, in which case, because every time you want to access the count, there will be a fresh computation. So you don't have to really update its value. It's always there when you want to compute. Okay? Okay, let's see, focus on this example here. Let me just do one more. I want to just link a little bit to Java, just in case you're still thinking in terms of Java. Okay? So uniform access principle is not just for Eiffel. It's a software engineering principle that's applicable to any language. How do we see this in Java, though? Okay, very easy. So let's say this. So now let's say we have a class over here. I would say point over here. So let's say for Cartesian system, I can say double x, double y. And now, the uniform access principle, this is how it applies. Remember in Java, we got something called getter or accessor methods, right? So let me just take x, for example. You can say double over here, get x. And then over here, in this particular implementation here, it's very trivial to get the x because we have stored that value there as an attribute. You can just return x. Don't you agree? Of course, for encapsulation, you will say private. Okay, private and private. And the uniform access is really here. So this is the uniform access. So uniform access means any client who wants to use your class, they're going to depend on getX and getY, the public methods only. How you actually store the attributes, they don't care. It's not going to affect them. So now let's say you change your mind. You don't quite like the Cartesian system. You want to change the polar system. Okay, what would you do? Let's see how you would do. I'm going to use the blue line. Let's say we change from Cartesian to polar. So how do we do that? Remember in the polar system, we store R and psi, right? So now this one go away. This one also go away. So we're going to say private over here, double. We're going to have the distance R. And also we got private, double, and here we got psi, phi over here. Okay? So now we got two different attributes, but they're private, so that's okay, they're hidden. So now anything else we got to change in the class? Get X, exactly. Now, do we change the implementation body only, or should we change the signature as well? Only, exactly, good. So you can see that's why it's called uniform access, because it doesn't matter which implementation you're really using, either Cartesian or polar, the interface is always the same, okay? So now we can say return, we can say R multiply sine phi, something like that. Okay, you can see that the yellow part, the highlight part, is the uniform access. It never changes. So for the clients, they cannot really realize you have made a change, right? Okay, question about this Java code over here before we go back to Eiffel. So in Eiffel over here, the issue is similar. So we don't really have the getter and setter. We don't have to declare this explicitly. So in Eiffel, if you simply in Eiffel, okay, I'm gonna write it here. Let's try to draw some connection to Eiffel. In Eiffel there, if I say class point, so I don't really have to say, I can just say x, which is a real number, and y is also a real number. In Eiffel, x and y over here is already obeying the uniform access principle, because you don't really have to define an extra getter method for that. Okay, but the idea is really similar. The way you access x and y is always the same, but whether x and y are implemented as an attributes or as a query is really hidden from the clients. I'll show you in just a moment in the code. Any questions about uniform access principle? Okay, good. I hope that's clear. Okay, let's go back there and then let's go over some code in Eiffel. You can feel free to try the code as well. We got Cartesian, we got polar. Okay, so now we got two implementation choices. Either you can store x and y as attributes, in which case you got to compute r and phi, right? Or the opposite. You can either store r and phi, and then you can compute x and y. Well, kind of the opposite, right? You can choose either one. Is it possible to store nothing and then compute x, y, r, and phi? No, right? Okay, I'm glad you're not thinking about that possibility. It's not possible. Good. Okay, so now here's the thing. What's really good about uniform access, as far as the user of a point class is concerned, they only care if they can say p.x and p.y. As long as these two accesses work perfectly for them, they don't care whether it's a Cartesian or it's a polar. Right? So over there, I'm going to, in the latest slide, I'm going to show you two versions of Eiffel code. Okay? And then we're going to compare them. Okay, let's see version 1. Version 1 is very easy. So over here, let's say we have a class point, and remember in Eiffel, you have to somehow declare the constructors, right? So now let's say we got two constructors. It can be either make polar or make Cartesian. So we are offering two possibilities for the user. They can either pass x and y, or they can pass r and phi, the angle. And now we chose to, let's say, and also from the interface view, you don't really know x and y, whether they are attributes or queries. That's uniform access principle is about. So far, we haven't decided yet. We haven't committed. Okay, so now, so we have, so you got two, you got different signature for make Cartesian, new x, new y. On the other hand, you got new r and new phi. Okay, so these are the two different combinations. Okay, so once whenever you're trying to access x and y, you just cannot tell which one it is. Okay, you can either go for storage, in which case x and y, they are simply attributes. Or you can go for computation, which means every time if the client wants to get x and y, you have to do the sine cosine computation, right? But how you compute that is irrelevant to the clients. Okay, let's say we do implementation number 1. What's going to happen? For number 1 here, so let's say we have a class called point, and we store x and y as attributes, let's say. Now, make Cartesian should be very easy, right? Because whatever new x you got, you can assign that value to x. Whatever new, there's just a typo, it should be new y. Okay? Whatever new y you got can be assigned to y. Very easy. How do you think we're going to do for, what's going to be harder? Remember we got another constructor, in which case we have to somehow calculate the distance and also the angle, in which case that'll be a little bit more difficult, right? Because now we only got x and y, okay? Okay, let's read some points over here. So we got attributes x and y, Cartesian system here. And so now when clients access, they will say p.x or p.y, okay? What does that really mean? Let's try to understand that for this version here. If you say p dot x, p dot y, there's no extra computation because you simply just return x and y, the values you store. So when should you use this and when should you not? I will have some discussion here a little bit later. So I would say in general, there's no really right or wrong answer, whether you should make your x and y balance or count either an attributes or as a query. It's really up to what you really need. Okay, I'll talk about that when I conclude the topic. However, now, if you want to implement this make polar over here, it's going to be more difficult because given some r and given some angle, you have to calculate the corresponding x and y. So you got to do some computation there. Okay, I'll just leave the code out. Okay, so that's implementation 1. That's the Cartesian system. That's version 1. Any questions? Okay. Again, don't lose the big picture. The way you access x and y wouldn't change between implementations. Okay, let's say this. I really highlight the word secretly. That means when you as a supplier, when you want to change your implementation, let's say from array into linked list, the client does not have to know. They don't have to know. You gotta have a good reason for that, usually for efficiency, usually for efficiency. Okay? So now let's say we secretly changed to implementation 2, but the way you access x and y are still the same. Okay? Let's say version 2. So now we don't store x and y as attributes anymore. Let's say we store r and p as attributes. Okay? Now, the way you implement this make polar is much easier, right? Because you don't have to do the sine cosine calculation anymore. You can just assign them nr to r, np to p. Okay? And now, the way we implement, sorry again for the typo, it should be y. I will fix that. Okay? So now for x and y, if you compare, just remind you about, in the previous implementation, x and y are simply just attributes. We never do any extra computation. Whatever the current value is, return them. On the other hand, in the implementation 2, whenever you say x, it is going to execute this block of code, which is going to say, depending on what the current value of r and psi is, you're going to calculate them, right? And then to see what the value is, and also for the sign as well. Okay, so x and y. Okay, any questions until now? I'm gonna fix the typo and then post the slides. Okay, so now here we got different attributes for the polar system, but for x and y, we still access them in the same way. But now we do need some extra computation there. But somehow the extra computation should not be the concern of the clients. Yes? I can look it up for you, but I believe there's some math library in Eiffel. I can look it up. So somehow I didn't really include the source code for you guys, but you can I will let you know what the necessary classes are. You can feel free to try. I'll let you know next time. Yeah. But in Java for sure, you can always find out the cosine and sine very easily using the math library. Okay, let's do something similar to this. Okay, so now this is what I'm gonna do. Okay. Basically, you know what? I'm gonna cheat. I'm gonna look at my slides quickly. Actually, yeah. Actually, I forgot to bring that slides in my paper. That's okay. So this is the example that's gonna help us learn. Okay. So now let's say this. Let's say if you can see the over here, right? So let's say this is the point we would like to get. Okay. Let me just okay. Let me just write it down on the iPad. I'll switch that in just a moment, and then I will show you. It's kind of easy to show you the equivalence between the two systems. Okay, so now I'm going to draw that over here. Just give me a moment. So A, 2A, A. Okay. Okay, for this particular example, we're going to somehow show you like that. Okay, so let's say this is the point. Okay, depending on which system we choose to actually build, right? So let's say, so here the A over here can be any number. Okay, let's say A here is simply just 5. And 5 over here. So now, in this case, the point over here, so there are different ways you can calculate them. Either you can say it will be 2a, for example, the x1 will be times sine 30 degree. Or you can say the 2a times the cosine of 30 degree. Okay, that's one way to see it. Or you can simply just store their values right away. Okay, so this is a polar system. And for the Cartesian system, in that case, you can just pass these values right away. In which case, in this case, what do we get? We get 5 square root of 3, and also we have 5. Okay, that's what we have. You can see you have a here, you got this one here. Okay, that's kind of the particular example that can work out. Okay, I can look at the triangle a little bit later. I'm just trying to tell you the example is based on this triangle here. Okay, let's now go and see how we can play with the code. And later on, you may find that for you to specify the angle, for example, in Java, they don't really allow you to specify degrees directly. You got to specify in terms of radians. In that case, you have some conversion there. I just included here in case you want to try. Okay. Okay. Now let's have a look at how we can play with the code. Okay. So now let's say this. Let's say we got a here. Remember, I got a here or over here, right? I got a, and then also we got x over here and we got y here. So that's how I set it up. I say we got a here. We got x, we got y. So they can be, a can be any number. It can be 5, can be 10, can be any number. And let's say we have 2 points, P1 and P2. Okay? Let's say over here. Let's say we simply set a to be 5. So the corresponding x and y should be just by using this calculation here. You can refer back to the triangle there. Okay, let's say we try to do this. We try to create a new instance of points with a P1 and then make Cartesian and x and y. Okay? Over here, can you actually tell, is it going to simply assign x and y, or it is going to do some extra computation? Can you tell? Over here. Or hold that question there. I also got another one, let's say point and then P2 that make polar over here. So you can see I simply give some value here and some angle over here. Okay, I just use some math. You can see so far the way we create the objects is simply by calling the public constructor. But do we actually know under the hood how are they going to represent the points, either Cartesian or polar? We don't actually know. No, we don't. Okay, let me just go a little bit further here. So now let's have a look at this line here. So now when I say P1.x is equal to P2.x, and also P1.y is equal to P2.y. Because of the triangle I showed you in the previous slides, so these two equalities should hold. But now, the main point is, I want you to look at line number 10 over here. So here we are in the client code. We are trying to make use of the points. Can you actually tell if a polar system has been implemented or a Cartesian system has been implemented? Can you? Can we? No, we cannot. Because the only way you can get access to x and y is simply by saying P1.x and P1.y, P2.x and P2.y. Whether the underlying system has been polar or Cartesian, you just cannot tell. It's not the concern of the current class. You simply just want to say .x and .y. How it is implemented, you simply don't know. Okay, further question here. Okay, remember we got 2 versions of the implementation. Let's say somehow the underlying implementation is Cartesian system, which means we store x and y as attributes. Let's say we consider this implementation. If you consider line number 8 and line number 9, which one is going to require more computing resources? 8 or 9? 9, right? Because if that's Cartesian system, x and y would just be attributes. So you can just pass them directly, right? But line number 9 is going to require more computation to convert into p and phi. Similarly, for line number 10, if we did the Cartesian system, would that be storage only, or that would be computation for line number 10? Do you have to do any computation to return p dot x? You don't have to, right? Because if that's Cartesian, x and y, they are simply just attributes. They can just return their values. Okay? So that's kind of the thing I would like you to look at. We are quite an informative client. That's why we are thinking about these possibilities. But typically, when you're using a library from outside, you don't really have to care. That's the beauty about uniform access principle. Because somehow, the supplier, they only give you a uniform access to x and y, but how they implement them, you don't care. The follow-up topic to this over here is to see another example where somehow the supplier exposes their implementation detail to you, and we'll see how disastrous it can be. Okay? Okay, so that's about implementation 1. Okay, so far so good. So now let's see one more discussion, and then we are done with this topic here. So let's say we did implementation number 2. We did a polar system. So now x and y, they are not attributes anymore, even though we are trying to say p1.x and p1.y. So now line number 8 and line number 9, which one should be more expensive to calculate? 8, just compare 8 and 9. Yeah, so that'd be 8, right? Because now it used to be line number 8 is cheaper, but now since we don't store x and y as attributes anymore, they're simply queries, so that'd be more expensive. Okay, very good. And now if we did implementation number 2, then in line number 10, in that case, is it cheap anymore? Not necessarily, right? Because every time when you say p1.x, you have to do some cosine calculation, and similarly for p1.y. Okay? So now, it's very natural for you to question yourself. So the uniform principle is nice. It tells me whether I choose to implement as a query or to implement as an attributes, either to computation or to storage. It's completely up to me. But how do I choose, right? I'll give you a little bit principle over here. Okay, so now over here. So first of all, there's no right or wrong answer. It really depends on the situation. Okay? So I would say for the simple example like a p.x, p.y, maybe it doesn't matter too much. Maybe using a Cartesian system might just be sufficient. But somehow it's just used to illustrate. You can have 2 different implementations. Now, I want you to think about the tutorial video that you're supposed to follow. If you haven't, let me just give you some background here. Let's imagine that we have a bank class, where the bank class we have, let's say, an array of accounts. Each account can do some deposit or withdraw. Let's say there is some feature, let me just draw it on the iPad. But that's something you should really try to follow the video so you can get a complete story. So let's say we have a new class here called bank. Okay, bank over here. And then we have an attribute called accounts. Let's say it's simply an array of accounts. Just that. Okay? Let's say we got one more feature. So this one is guaranteed. This one is, let's say, it's attributes. It's already fixed. Let's say we have another feature over here, and then we have, let's say, it's a real number. Okay? So this one here, let's apply the uniform access principle over here. Okay? So over here, so this can be attributes, or it can be query. Either one. From the interface, we simply cannot tell. It can be either attributes or query. So now we want to know when should you choose attributes and when should you choose query, right? So here's the kind of like a principle, okay? So now, when you choose attribute, what does that mean? That means you're trying to avoid computation, right? So, for example, let's say you have a very large number of clients. Large number of accounts. So let's try to think, let's prove by contradiction, a little bit like that, okay, by negation. Let's say you got 1 million accounts in the bank. If every time I want to know about the balance of the account, I just have to sum up all the 1 million accounts together. In that case, the computation will be very expensive. In that case, maybe having the attributes will be better. You can simply just return the store value rather than running a loop and then go over all the 1 million account to do the calculation. Okay, so that will be the good point about choosing an attribute rather than computation. You can save the resources. Okay, and also attributes should be when you have frequent access. If every so often you have to call bank.balance, then you may want to save the computing resources. You don't want to go over the 1 million accounts every time. You can simply return its store value. Okay, it's more frequent access and less frequent change. Okay, that's kind of the criteria. On the other hand, what can be the advantage for query? Think about what you would do for lab number 1. If you declare your, let's say your account feature as an attribute, then what do you have to do? You have to worry about whether to decrement or increment or stay its value unchanged for every feature to see which one is the appropriate one. Because you always keep the value of the attribute in sync with the rest of your system, right? That's the catch. So over here, and also let me just say one more. The good thing is we don't have to keep the value in sync for every feature, because every access is a fresh computation, right? A computation. Again, it depends. If you got a very large size of clients, in that case, you may have to think about attributes. If you don't really have that large number, but you have you simply don't want to bother to actually update the attribute for every command or every query. In that case, you better choose query. Okay? So there are 2 criteria here, 2 possibilities. Okay. Any question about this? So let's go over some slides. Okay, quickly. It's also written down. Okay, let's say you might choose a storage if the bank involves a large number of accounts. So you don't want to do a huge number of computation, right? Every time you call the balance. So that'd be a good place to use attributes. On the other hand, if you want to choose for computation, why would you want to do that? You don't want to bother to keep the attribute value up to date every time you change something to the account. Okay, but again, once more, the uniform access principle is really for the client's benefits. Whenever you as a supplier change anything in your code, it should not affect the way the client uses your code. Okay? But whenever you want to change your code from one implementation to another, you better have good justification. I can do that without affecting the clients. Okay, any questions? Are we okay? No? Are we okay? Okay, good. But we will actually review this issue here maybe at the end of today or the beginning of Wednesday. Okay? Not yet? We got 5 minutes, right? Guys, you know what? In some way you pay the tuition. You should want more time with me, right? No? Maybe the opposite. Okay. Let me talk about something very quickly, and then we are done for today. 5 minutes. I want to talk about generic parameter. It's actually very useful. We'll talk about from a more theoretical point of view when we talk about inheritance later. But now I want to give you a very intuitive view. Very easy. Let's say now your problem is you want to implement a string stack, which means the stack stores strings only. How would you do it? Okay, let me show you some very intuitive implementation. Let's say we use an array. Okay, the way we do it is by saying we have some implementation array of string, and then we have some counter here. So now rather than growing the size every time, the I over there points to the top of the stack. So we don't have to grow the size every time. Let's say we got very large size array. So we simply use I to tell us where the top is. Every time you want to push or pop, simply increment I or decrement I. Okay, that's one implementation there. What about count? It simply returns the value of I. What about the top? Since we are storing a stack of strings, top is going to return the string and then return the last one. Okay? And then we have push. We can push a new string into the stack, and then we simply just increment I. We can also pop, in which case we simply decrement I. Okay? Now, what can be the potential drawback for this design over here? Well, I can tell you the stack class itself is okay. It works. But whenever you're developing software, think about extensibility. Let's say I want you to do another class called stack of accounts, which means we're going to store accounts only rather than strings only. Are you going to create something very different or something fundamentally the same? Fundamentally the same, right? I want you to pay attention to this code over here just for a few minutes. So now, let's say we talk about, let's focus on the top feature there, the top. It returns a string because it's a string of stack of strings. Over there we say implementation at I, right? We simply say go to the array there and go to where I is pointing to. In this case, does it really matter the type of the elements we are storing? It doesn't matter, right? We simply just want to go to the last one. Similarly, if you go to the push, also, it doesn't really matter which element, what's the element type, either string or count. We simply assign the value to the last and then increment the I. So the way we do the updates for the stack is kind of irrelevant to the type of the elements, right? So that's my point over here. Over here, let's say somehow you're not really, even though you're using the string, but you're not really using any string specific feature like an add or append. You're not. You're just reorganizing the order. And you also get so now how would you do a count stack? You're basically going to repeat everything except that the yellow highlight part is going to be a count. Okay? So now that's justify why the design is really bad. Okay? Okay, I know you're very keen. Okay, now let me say this. For lab number 1, the due dates will be Friday noon. So you got a lot of time to really write good tests, so there should be no excuse for you, right? So if you really got question about how to write post-condition tests, drop by my office hour or write me an email. And then on Wednesday, I'm also going to release lab number 2. You can either start with that or you can work on lab number 1 still. Okay, I'll see you.